Okay, you've already seen the video that introduced you to different kinds of footings, and now we're going to talk about how you calculate the size of footings needed, or determine if the footing is good enough for what your purpose is. So we've seen this before. All of our weight is basically being carried down our columns onto our footings. And then the footings are carried on our soil, which we've talked about different kinds of soils and how much weight they can each carry. Take a minute and look at this. Pause if needed. This is the same kind of information we've seen before. And we've seen this before. The load is carried down and then it all ends up on our soil at the bottom. Soil bearing pressure is often with the variable Q because we use P for load or force. P is load or force. And then the area of the footing. We're talking about the flat horizontal area, not the depth or the height of the footing. We've seen this chart before several times about different kind of soil types and the bearing pressure. Now what's important to catch here is this is the allowable soil bearing pressure. We get this allowable from the soil itself. That's from the previous slide. This is the allowable pressure. How much we can use is based on the soil. This is the Q that we calculate is coming down from our building. We want the soil to be able to hold up more than our building is pushing down. So our building is pushing down force divided by area of the footing. And therefore, if we just do a little algebra with this, we'll see that the area of footing we needs to be more than the force divided by how much the ground can support. So what we do is we calculate the net pressure per square foot of our footing. We also need to calculate up the weight of the footing itself using these formulas. The footing itself, since it's made of concrete, is heavy, so we have to subtract that off how much the soil can hold up to get what we can have from the concrete. In other words, the weight of the footing itself is also being taken into account here, giving us our final formula. You should write this down. So we're going to consider a column here, this column coming down, and there's a footing at the bottom. We've seen this picture before. And that's the beam they're talking about. So they're just going to add up all our forces. In your working problems today, you're going to have already added these up to find out how much force is on your footing there. If you're really doing it for a building, you'd have to calculate each one of these items, like we've learned how to do in our previous sections, and then add them all up to get our final total. Here's our final total for our example. So we first start with the thickness of the footing times our weight of concrete to get our pressure provided by the footing, pounds per square foot. Notice this is not the total weight of the footing. This is just each square foot of the footing, how much 1 square foot is. We subtract this number off of what we got for our kind of soil. The soil could take 3,000 minus how much our footing itself weighs, giving us the amount of pressure we can have coming down from that column. We now put in our column amount here, divided by what we just found in our previous section, to get how big our footing needs to be. Our footing needs to be this many square foot. We can make a square footing, rectangular, or circular. At this point, they're going to say, what if we take this 41 and make it a square footing? And we just take this, do a little algebra, take the square root of both sides, and find 6.4 feet. However, no one's going to build forms that are 6.4 feet. They're going to build forms, or they're going to have forms that come in the closest 6-inch or closest 3-inch rounded off. And we're going to be asking you for your questions to be answered that way. If we wanted a round footing, we do the same thing. Notice that we got 3.6 here, but we rounded up to 3.9. Even though this is closer to 3.5 feet, we'd always have to round up to make sure we have enough strength. And that's how you do it.